Hello, and we are back. Or is that may be copyrighted? Hello, hello, we are back looking at some PS5 power supplies. I am back a lot earlier than I usually am. Are we working? I can't tell. Refresh this page. We don't seem to. Oh, there we are. I am going to continue on this power supply that I was working on yesterday. Hello. I wasn't sure if I was actually streaming or not. It showed that I was, but there was no one here. Good morning, King Nothing. I got your email that you got the board back. I'm glad it worked for you. Welcome, welcome. I guess it takes a little while for those notifications to propagate out. I am back working on this PS5. You're quite welcome. I'm glad it worked out for you. We're back working on this PS5 power supply from yesterday. Trying to. I have been working on it. I have not fixed it yet, but I think I found the source of a lot of its problems. Well, is this working? I apologize. Trying to mute my mic as I'm having some coughing fits. I'm still getting over upper respiratory infection, strep throat from a few weeks ago. Lots of antibiotics. Feeling fine. I don't know. I get into coughing fits sometimes. Okay. This is our supply. This is one I'm comparing to up here. A working 400 FR. This is the one that's not working for us. And I'm not sure. Some of you were here yesterday when I was working on this thing, and I gave it. It would not start, and it seemed like the supply pin was being loaded down. That's what it seemed like. Which the supply is internal. We kind of talked about that some on the data sheet for this DAP053. It's internal from the drain of the PFC, as a current source, not a very strong one. Supposed to supply current to that pin and just enough to get it started. Anyway, that wasn't happening. But if I fit in 19 volts into there from my bench power supply, it would run. But it put out like 1.5 volts. So there was some weird stuff happening with it. And I broke out the thermal camera yesterday and started looking at it. All right, it was, when I would apply the 19 volts, or was it without applying? I can't remember if I did it with or without. What I was noticing was a couple of things getting warm. Of course, the IC itself gets warm. It's not on here right now. The IC itself would get warm, but also the gate circuitry feeding Q4, one of the MOSFETs, would get warm. because there was like 7 volts going there. I don't know. So I was trying to figure out is why is there a voltage? The thing's not running. Why is there current going to that MOSFET? There should be nothing going to that MOSFET, but there was. So anyway, I got to checking, looking at resistances, and finally figured out. I was measuring between like between the gate and the source of these of Q4 and Q3. There's some 10K resistors. Where is that? Yeah, right over here. See these 10K resistors? One here, from the gate to the source. Gate to source. I measured 10K here, as you would expect, between gate and source. But here, down here on Q4, I was getting like 9.8, which I thought was odd. I think it was 9.8, yeah. Anyway, and I was getting that. You see this goes back to the DAP053 here. Pin 6. This chip was out. I didn't have it in here. It was gone. There was no chip in. So where was this lower resistance coming from? There was not another path. And that's what got me looking at the MOSFETs. Let me get over here. It got me looking at this MOSFET. Hello, hello, welcome. And if I can show you here, let me switch back. Turn that off. Q4, the low side MOSFET for generating 12 volts. Which one is which? I think, which one is this one up here? If I measure between gate and source, yeah, that's the bad one. 100K ohms. If I measure, I think, between gate and drain even, yeah, a megohm, which that should not be. Here's a good one. Here's an identical 18N60M2 right down here. Gate to drain, gate to source. Infinite, or beyond the limits that this meter can measure. I think this meter measures like 200 megohms. But, so, yeah, we have a leaky MOSFET, Q4. That's not all of our problems, though. If I can show you, I had never made it over to the cold side of this board, the right side, as I've got it laid out here. We never even looked over there because it wasn't running. So, and this is a controller. This is going to sends shutdown signals. It does the regulation. It monitors temperature over here. Anyway, let's look at that DMP014. That's what it does. It's overall controller, you might say, for regulating. Pin 1, 0.06. Pin 2, 0.03. Pin 3, 0.3. So anyway, pin 4 is it's very, very shorted, which is probably why when I forced this 19 volts into this DAP053 over here, it ran, but we got 1.5 volts out. So we're probably lucky it ran at all. So we've got a bad DMP014. This is looking more and more like lightning damage, the way it's... We have damage on the hot side and the cold side. The original, some of you may have been here yesterday, the original thing I noticed on this one, that on that controller chip, the DAP053, pin 16, that was the only pin. Pin 16 was shorted to ground, which is the feedback voltage from over here. It comes through an opto-isolator. So anyway, but somehow we've gotten damage on both sides. The cold side, which goes to the console, to the PS5, and the hot side, which hooks back to the AC line. Both sides have damage. Now I had lifted, if I can show you, I had lifted, there's a capacitor I was lifting, I got to put that back. I had lifted this Zener and this capacitor. They're fine. I put them back on there. and I've swapped this chip out a couple of times. I thought it had to be a chip breaking down, but no. It was a bad MOSFET. So I've got another MOSFET. I haven't put it in there yet, but I'm going to. I need to remember to spin this capacitor back around. Put another chip on here, either a TEA2016 or a DAP053, whichever. And, oh, I got a jumper right here. This is the jumper I lifted, you know, separating the supply into this chip from the circuitry that normally, you know, at runtime would send it voltage. This is a little transistor right here. That's its job. Anyway, so I need to spin that capacitor around. I'm going to have to replace this DNP014. It's very shorted. So, yeah, a lot of work to do. A lot of work to do. Welcome. I guess most people are watching Joey this morning. That's all right. That's fine. Oh, I see Andy is fired up. I wasn't sure if he was going to start. That's all right. You know, they can watch this stream later on. Let me put, what the heck? Let me put Q4, put the good one back in there. Which I need to confirm is this bottom one right here. Yeah. Yep. That's the bad one. Stick it off to the side here. This is the good one. So let me clear these pads off. Where's my solder wick? Where'd it go? Oh, somebody put it in my drawer. We'll clear these off. Come on. It's going to fall out as soon as I let go of it, if I don't bend a leg or something. Okay. Now we've got it captured there. All right, that should take care of our leakage issue. I need to spin that capacitor back around, put a DAP053 back on here. I was chasing that leakage, you know, that was making that gate to source reading lower than it should have been, and I started lifting some capacitors and looking around. And finally came to the conclusion it had to be the MOSFET. It was the only thing left on the line. Right there's a DAP053. It's one we were testing with yesterday. I hope it's still good. Because after a while you start doubting things like, you know, have I done something during testing that I've damaged this part that was a brand new part out of the package? Did I do something to, you know, to damage it? But I did try another, you know, a cheaper TEA chip. Neither one worked, so I'm thinking this is still good. Where's my small diameter solder? A small scrap piece of it here. Welcome. Morning. Kevin. Oh yeah, Kevin. Kevin Mawson. I remember your name. All right. So that's back to normal. Oh, I know I need to put this jumper back. And replace that DNP014 on the other side. And then we may find that there's other damage. That's a possibility. Some of you who are maybe in here watching, these were power supplies given to me by a gentleman in the U.S. He lives in Florida. I'm not sure if he has a shop or if he's just a hobbyist like me. I'm not real sure. I think his name is Chip. He sent these to me just for free out of the kindness of his heart. So I was thankful to have something to work on. All right, that is back. That's a jumper we lifted isolating some stuff yesterday, trying to track down a problem. Oh, there's another diode. I forgot that I lifted 2 diodes. Wow. I did that this morning and already forgot about it. This is in the gate drive circuitry for Q3 and Q4. These MOSFETs up here that generate your 12 volts. And I was looking for that weird reading I was getting on the gate. So I wanted to check those diodes. They're kind of hard to check because if you look, there's a 150 ohm resistor in parallel with them. So when they're in circuit, it's kind of hard to get a good reading on them. You're going to measure like 0.15 or whatever, because all diode check is a constant current. At a certain voltage, limited voltage. Alrighty, so those are back in circuit. Like I said, this is in the gate drive. Here, this is the one for Q4, and this one over here was the one for Q3. And that 01C, that's a 10K resistor from the gate to the source, from the gate to the source. What else did I lift? All right, I know I've got to take out this DNP014. So I might as well do that now. I know it's no good. It has many shorted legs. Many. Hello, Chlor Slug. Hello. Peter, I'm continuing on. We fixed the first one I started on yesterday. This is the second one that I didn't get finished with. I did not get finished with it yesterday, and we are continuing with it today. I did look at it some yesterday evening after I got off the live stream, and again this morning, and I found a MOSFET that had broken down. Q4, one of the big power MOSFETs for generating 12 volts. Was leaky. It did not short entirely, but it was leaky gate to source and gate to drain. Like gate to source was 100 K ohms, gate to drain was like 1 meg ohm. And that was giving us some weird issues. As you can imagine, DNP014 is out. And I know it's bad. A lot of shorted readings on that one. Where are they? I got a lot of overhead bins. I'm trying to locate the DNP014. Where did I put those things? At one time, I kind of made an effort to group things together. Power supply stuff, HDMI stuff. At some point, I think that went out the window. Or I'm just not putting drawers back sometimes where they should be. DNP014. I need one. Oh, I see them. I see them. How many of these do I have left? I've used quite a few of them. Looks like I got at least 10 or so left. Oh, no, just don't do that. Just don't put it backwards. Don't want to do that. See if I can push it down any. Still got that glue under it, kind of holding it up. And sometimes I actually grind that glue away. Let's see. There we go. Okay. What else? That chip should read good now. But I wouldn't doubt as much damage as there has been. There may be some other issues. Red probe on the negative terminal of the output there, over here. Pin 1, that's much better. 2, 3, 4, 5, 6, 7, 8, I believe is ground. Yep. 9.13, I think that is normal. 10, it seems low, but I think that's normal. 11, that does not sound normal. 12, 13, 14, what's 11? And why is it so short at the ground? 11. Pin 11. One moment. Pin 11 of the DNP014 over here. Pin 11 is normally 0.244. That's part of the current sample. It's where it brings in the 20. I see a diode and a zener out here. Of course, a tiny 100 nanofarad capacitor there. Hey, Steve. Good to see you here, sir. Welcome. I hadn't heard from you in a while. You fell off the face of the earth there for a while. We're chasing down some damaged power supplies. This is a ADP 400FR that apparently has had quite a bit of lightning damage to it. It's got damage on the hot side and on the cold side. And I just changed out the DNP014. I still have a short on pin 11. So just about has to be. I need to make sure I don't have a short across the output terminals. Let me check that. Make sure I don't have... Oh, you've had the flu? Oh, I'm sorry to hear that. Sorry to hear that. I hope you're on the mend now. I hope. Let me go back. Turned off the wrong camera. I just want to do a quick check across the output terminals. That doesn't look right. 32 ohms. That should be, there's a lot of capacitance, of course, on the output. That should be climbing like crazy. It should not hang at 32 ohms. So where is our short? This thing is just full of problems. Where's our... Here we go. Our MOSFETs are down here for... am I zoomed in? What they call synchronous rectification. They're using MOSFETs as rectifiers. Anything shorted there? No. No. Wait, there. That's 32 ohms again. So where is our short? It's pin 11. There's a capacitor. Make sure I got this right. 8, 9, 10, 11. Capacitor. You can't, okay, there's D131 and ZD131. Of course, I'm going to measure that 32 ohms across there. Oh, it's even lower. It's 16 ohms there. So I was getting 32 ohms across the output because there is a 20 ohm resistor isolating you there. Should get like, that's 0, yeah. Yeah, 14. So I guess let's lift a Zener. One's just a regular diode, and one of the others is a Zener. Let's see if we can lift this. Hey, Roy. Yeah, I'm starting a lot earlier because I started late yesterday and I just kind of run out of time. I was having to get stuff to cook dinner for my wife and I just plain ran out of time. Had to run to the store, so I stopped working on this power supply. And we are continuing on. This is the second one from yesterday. I don't know if it's this Zener, but it's easy enough to lift them and just kind of... That's a regular diode, and this one's a Zener. Oh, don't do that. Kind of stay where I put you there. Yeah, like that. Make it easy to check. Get out of the picture. I'm sorry. So I've lifted those that diode and the Zener. Let's see. Either one of these happen to be measuring like 10 ohms? Nope. Ah, that one's 13 ohms. D1. It is no longer dioding. I don't think that's a word. I made that up. It's no longer rectifying. And this Zener, I hope, is good. I'd have to take it out of the circuit to test it fully. I mean, obviously it checks good with a simple diode. Whoa. Wait a minute. I'm in resistance mode. It's measuring 1.4 meg. That's suspicious. 0.7, maybe normal though. Let's see. What does it measure resistance-wise in the other direction? Okay. 1.4 meg this way. It's probably all right. D1 is not all right though. D1, it is D1. Or no, it's not D1. It's D something. D13. What did I say? It's D131. I have that labeled as being an S4. Yeah, that is what it's marked, S4. It's just going to be a very common diode, though. Yeah, to be continued. We're back. We are back. Welcome. Welcome, welcome. I need to replace that. I don't know if it's 1N5819 is what that is. Which, let me look up the data sheet for a 1N5819. I don't think it's anything super, strange or special about it. 1N5819. 1 amp, 40 volt. Oh, it is a Schottky. It is a Schottky. So it's going to have a low forward voltage. Low forward drop, 0.45 to 0.55. Fast recovery. I don't think I've got, it's just a 1 amp diode, but it's rated at 40 volts, Schottky. So do I have a similar Schottky? Or I'm probably going to take one off a donor. I mean, I have a lot of diodes, SMD diodes, up in my parts bins, but they're not, I don't believe they're Schottkys. And that number, that marking code S4 doesn't sound familiar to me. BAS 316, BAS 416. They're just common diodes, I believe. I've got those. Do I have a parts board? I do. I gotta move one. I've got too many boards out right at the moment. Only so much space on the workbench. Alrighty. That one. D131, S4. I will take you. I don't have those on hand because I don't think I've ever had to replace one of those. I have on hand, obviously, the most common things. Lost my solder again. I have the more common stuff, the more garden variety things. The MOSFETs, the optical isolators, these DMP014s, DAP053s. Some of the other Zeners around that on the other side, around the DAP053. I've got some of those. If I've replaced it before, I probably have it. Okay. Try not to lose it. I do need to check right quick, let me make sure that 20 ohm reading is gone on pin 11. 7, 8, 9, 10, 11. Yeah. With that lifted, what you're seeing is those capacitors charging up. There's probably 20,000 microfarad in capacitors on the output. So that looks good. Let's get rid of, where'd it go? Let's get rid of that one. And spin that other one back in place. Actually, it needs to be moved down, doesn't it? I've got you. Put you over here with, oops, and that one just took off. I think I see it. Sometimes they like to take off in a hurry. Oop, like that one. Where'd it go? Oh no, that's not good. I think I do have some of those if I've got to. 'Cause it may have just left. That was a Zener marked ZM. Where'd it go? I think it went in the floor. Odds are not in my favor to find it. Where's that donor? I don't think it's stuck on the board. I looked. Oh, there it is. There it is. I got lucky. All right, let's see if we can do a better job of it this time. Looks like I need a little, could use a little solder on that top pad. Let's see. All right. Once again, just don't let it leave this time. You turn down the airflow. And there is S4. Which end is the cathode? Oh, there's the stripe. Don't you do that. Let me get hold of it. Where's that stripe? There it is. They're both oriented the same way. Now, get on there. And knock it in there. All right. Finally. What else? I'm hoping I haven't lost one of these opto-isolators. They could have gone. I should measure about 1 volt from pin 1 to pin 2 on these things. Let's see what I get in diode mode. Yep, that looks right. That looks right. Okay, maybe our opto-oscillator survived. Seems like I've had this 100 ohm resistor fail before also. She's good. That 20 ohm we know was pretty good. Alright. And we don't have a short on our output. We just see a bunch of caps charging up. Yep. Alright. Unless I'm forgetting something, I think we're ready to check it out. Unless I've lifted something, I put that jumper back. Unless there's something else I left, during troubleshooting. Got a MOSFET back in it. Okay. Let me fire off the DC load back there. Oh yeah, you can see it. Maybe even get set up where I can monitor the power factor correction boost voltage. Hello, hello. Oh, worms. This is it. This is the one. This is the second one, the one that I did not get fixed. We're continuing with it. We did find some other problems. We had a MOSFET Q4 that was leaking, breaking down. Swapped that out. We had this DNP014 on this side was just completely shorted. And we just replaced a shorted diode, also D131. So pulled that off a donor because that's a shot key that I did not have on hand. Probably should get some of those. I may have a shot key and just don't realize it in one of these parts bins, but it's not that number, I don't think. Maybe it may be something similar that would have worked. I'd have to just go through and look at the data sheets. All right, let me see if I can get hooked onto this big capacitor here. Okay, got that. So, load is set for 5 amps. Turn it on. Oh, the AC is still connected into it. It is turned off. I've got this dialed all the way down. I'm going to try to bring it up slow. See what happens. Maybe I forgot something. Maybe I didn't. Let's see. On, but we're turned all the way down voltage-wise. And if I start easing it up, I want to check this current. Yeah, current's staying pretty much zero, as it should. Yeah. If I bring this on up, hey, look at there. Finally. So, yeah, we had a lot of problems on this one. But she's working. I need to check it. I'll check it at the full 31 amps. But, so yeah, there's a lot of parts went into this one. What was it? Probably the main culprit was this Q4 MOSFET was leaky. It didn't short, but its drain to source is 100 k ohms. And I'm sorry, gate to source was 100 k ohms. I think gate to drain was measuring like a meg ohm. And that's what was giving us the weird behavior on that DAP053. I don't know why it was. I've never seen them act like that, but apparently that leaky MOSFET, the gate circuit being leaky, wreaked havoc with that thing. But on top of that, the DNP014 over here, which is the one that handles the feedback, you know, it monitors the temperature over here, it handles over voltage, over current on the 12-volt output, the feedback. It was just shorted about every way it could be shorted. It would just say completely failed. And I didn't see that yesterday because I never made it to that side, never made it to the cold side. I was focused on the hot side of the circuit because it was not running at all. So pretty much some kind of lightning damage had to have happened to have done this much. And also, if you're just joining us, the last piece of it was the replace the chip. There's also a shorted diode, D131, which is, let's see, we were just talking about that. It was right there. After replacing this chip, the DNP014, I still had a very low reading on pin 11. That was the only place it remained, but there was before replacing it, it was shorted on 1, 2, 3, everything was just shorted. And after replacing the chip, 11 was reading really low. And that turned out to be D131, which is a Schottky diode. The Zener is okay. I did not replace it. Yeah, leaky things kind of, weird things start happening. You know, they like to break the laws of physics and stuff. Alrighty. And I did not. I got started this morning. I'm sorry to say I went ahead and I wanted to. Before I was ready to stream, I wanted to go ahead and do some checking. And it was weird. I almost didn't find that MOSFET. But I was comparing to another board. Let me shut this thing off. And I'm going to put it off to the side here. This is the working board I was comparing to. And I was checking, I was looking for anything to explain the weird behavior I was having. And I had not, I had checked these MOSFETs Q3 and Q4 on that other board. They weren't shorted. I had checked, they were not, there was no short. But I went back and I was checking, like if you look at well, I'm sorry, let me switch back. If you look, where's my diagram? At the Q3 and Q4, which drive the output transformer. Gate to source has a 10K ohm resistor. And that's very common. I notice on these Delta power supplies, they do that a lot. If I'm not mistaken, there's even one on the PFC up here. Yep, right there. So I guess that's common with MOSFETs like that. But I measured, let me switch back. Like I checked on Q3 between the gate and the source in resistance mode. And am I in the right place? Make sure I'm looking at the right power supply. I've got several laying around. Oh, the resistor's gone. Why did I take that resistor off? What did I do to this thing? That needs to be there. Did I knock that off? Okay, need to put that back. Huh. Apparently I removed that. But I would measure 10K from gate to source. And just like you should see it over here also, since I haven't taken it there, 9.98. But I was getting like, it was like 9.7 or 9.8. It was just as weird. It wasn't, and I took the chip off and I still had it. And like the only thing left was the MOSFET. And when I took it out, sure enough, it was leaking between gate and source and gate and drain. So I need to remember to put that 10K resistor back. I don't remember removing that. Okay, so I think we're done with this one, but let's give it a good check right quick. Let's give it a quick check at the full, how am I tangled up? 31 amps, okay? Let's see, and I will get set up to measure the output voltage just so we can get a little, let's see. Yeah, you can see the load over there. And I guess we have no output. Stay right there. So if I turn this back on, we should have put out 12 volts. And we do. All right, at a 5 amp load on the output, see I'm drawing 6/10, 7/10 of an amp. So let me show you. If I crank this up to, let's say 10 amps. See now I'm running about 1.25 amps. 11, maybe 12, 1.5 amps. It's a 2 amp fuse on this output, so I can't go much higher than 12 amps on the output, or I will blow that fuse. So, yeah, there's voltage, there's amps. Doesn't move much, it just happens to be in the same spot. There's voltage though. So, yeah, I need to go straight to the outlet back here, so we can get a few more dBs into this thing. All right. All right, now we're straight into the wall. 11.996 on the output, and I'm going to crank it up. We're at 12 amps already. 13, 14, 15. This is staying rock solid. 16, 17, 18, 19, 20. So far, so good. 11.992. Can't complain about that. 21, 22, 23, 24, 25, 26, 27. The fan's kicking up on the load here. 28, 29, 30, 31. 11.983, 39. That's you can't ask for better than that. That's full rated. It'll go to 32 also, see? I don't like to push it though. Yeah. Beautiful. That's about all you can get out of these things. It's pretty good. Okay. So this one needs to be cleaned up a little before I put it back together. Like the last one, I still got to take the other one. The first one yesterday, I put it back together without cleaning up the flux off the board. I didn't realize it till after I'd done it. I take that back apart. Oh, I slept wonderful. I knew I'd come back to it. Oh, right. Yeah, Cason. Y'all talking about Cason? I ordered a lot of stuff from Cason, but you gotta wait. No, that main board will never pull 31 amps. If I had to guess, the most it would probably ever do might be 20 or something. Somewhere in the low 20s. That's just a guess. I don't have a power supply that would deliver it, so I can't really test that theory myself. But I don't think they even approach using 31 amps. I'm sure they oversized it a certain percentage, but okay, let's unplug this and unplug our output. We are still the board is quite spicy at the moment. We need to discharge this thing a little. Okay, we're down to 3 volts. I think that's safe enough. I think that's safe enough. All right, now let me get some paper towels. Apply a little heat to this. Give it a good washing. Just trying to make it warm up a little. So this flux will more voluntarily come off. Set it up on its edge here to wash it. I love the smell of alcohol in the morning. All right, what did I miss? What did I miss? Oh, I need to clean out from under that chip. Yeah, I'll get it. That looks pretty good, but I know I left some under this same thing I did on the other one I worked on. There's flux all up under that chip, and I don't like to leave it there. It's under there. Let's heat it up a little. Maybe a little flux under there, just a little. All right. Some of these Kim wipes. Try to make it look like a halfway professional repair. Ugh. Because I had touched a lot of parts of this board. Bound to have a little flux left over. All right. All right. I like it. What are we talking about? All good? What did I miss? Oh. It takes many hours. You prefer the taste? Well, don't we all? But it is rather early here. What do I do with the covers? What do I do with the covers to this one? It's not in the floor. Oh, there it is. Alrighty. Another ADP 400 FR saved from the scrapyard, or from the landfill. Let me put an official looking label on it. ADP 400 FR. Repaired. Yeah, and tested. 231 amps. This is just for me to know. Find my tape. Because I found out a long time ago, if you don't start labeling things, they all look the same once you put the covers back on them. They all look the same. And I will not remember what I did to... I need to put some screws in this one. You think you'll remember, but you won't. Alrighty. I think I got it. Yeah, it didn't quite snap back together on that side. Okay. Put this out of the way. Do we want to move on to another one? I need to put this... Trying to keep up with the one I need to take back out and clean. Yeah, okay. Do we need to move on to another one? That was on a different board. That was on a That missing 10K resistor was on another board off to the side. Yeah, the DMP014s, the time I bought them, it's been a while ago, I got them from Case and Parts. Hello, Sarah. What's next? What's next? Well, there are 4 more in the floor here. I can just randomly grab one that looks easy. That's another FR. Yep, it's power supply day here. Now I need to, I think this is a TEA chip that is still good. Yeah, let me hang on to that. It's one of the ones I tested in another supply. I need to throw away though this other DAP53, DNP014, MOSFET, those all need to go away before I try to put them back in something. All right, we're going to move on to another ADP 400FR. As used in the 1215 series, or 1216. I think over in Europe there were 1216s, not 1215s, but the 1200 series, that family of PS5s. I do have a PS5 back behind me to work on. I haven't opened the box. There's another one coming in today. Now another one over here I've been testing it for a while. But yeah, I'm having a hard time finding PS5s to work on. The prices have gotten stupid. Oh, I see soot. Yeah. I'm not sure if that's showing up on camera. There's black soot in this one. Something went up in flames. Unless this is just dirt, but it's very black dirt. And you can kind of see it on the inside of the cover here. That dull gray look. What went up in flames? Well, there's some dark dirt on the side of that filter cap there. Is it just dirt? It looks like soot. Let's take a look at this under the microscope. See if there's something that's burned up. I'll take microscope. Is there something? You see this stuff? Is that just dirt? Maybe it is just dirt. Because it looks like it's been in there for a while, the way it's kind of swirled around on the board. I don't see anything, you know, burned. So is it just dirty? Okay, maybe it's just dirty. Some awfully black looking dirt, but okay. All right, let me switch back. I don't see anything too bad looking. It's all over the place. It does look like it's just dirt, I suppose. It does look a little bit burnt though. But then again, you don't know the environment the things are used. Maybe it was used next to a, you know, wood-burning fireplace. You just don't know the history sometimes. All righty. Diode mode. I'm in diode mode, which it'll beep if there's a short. I was going to check the fuse right quick. Like, is our fuse good? Yeah, it almost always is. And is our fusible resistor good? Which is right here. It's good. How about the output? Yeah, no dead shorts there. So nothing shorted should work. Not necessarily. Let's look at our old friend, the controller for all of this madness, the DAP-053. Pin 1, 2, 3, 4 is ground, 5, 6, 7 is no connect, 8, 9, 10, 11, 12, 13, 14, 15, 16. Nothing shorted. Well, then there's no problem. All right, just for the heck of it. I have not plugged this thing in. It may work. I kind of doubt it. But I have not plugged it in. Also didn't discharge it because I was pretty sure it was dead already. It could have given me a surprise, I suppose. Pin 1, I'm going to check this DMP-014. 2, 3, 4, 5, 6, 7. 8 is ground, 9. Yeah, that's normal. 10, 11, I think that's normal. 12, 13, 14. Everything looks fine. So could still be a bad, you know, DAP-053. I mean, none of the MOSFETs are shorted. I wonder if our PFC voltage is. I mean, this stuff here is kind of high impedance. This is the divider for the PFC boost sense voltage. This is what senses the 400 volts, 395 volts. And those resistors have got dirt all over them. So it's possible that if it is running, our PFC voltage is kind of taken off because of the dirt. But nothing reads shorted. Is that burned? Is that just dirt? See that resistor? It's just dirt. Looked like it was burned, but it's just dirt on it. I would just give it a good cleaning, but I was worried there was something, you know, burned somewhere that I need to see where the, you know, where most of the soot was collected, but it's pretty much equally distributed everywhere. Let me check on these opto-isolators here in diode mode. Looks good. That looks good. I think that's all fine. Remember this. This is IC51, 0.565. I think it's no reading on one leg of it, and 0.565. Let me check that IC51. Let's see. Oh, wrong thing. I'm not thinking about it. IC51. Yeah. 547. So that's normal. Sounded a little bit low, but it's just, that's what it normally reads. Okay. So, in theory, this thing should just work, but I have a feeling it does not. Maybe it starts and shuts down or something. I think we're about to find out, though. I mean, nothing shorted. Oops. Make sure I get these leads right. I can tell you my electronic DC load does not like it when you give it negative voltage. It does not like that at all. Okay, I would like to see that PFC voltage. It's always just kind of a good thing to watch. These caps aren't swollen or anything, though, so I don't really have any reason to believe that they've been exposed to too much voltage for a long period of time or anything. All right, so we're checking across the large filter caps there. Load is set for 5 amps. That's nothing to this thing. Get some AC in. I need to move my board a little, looks like, don't I? And we got some glare there. Get rid of that glare. Okay. We have our load, we have our AC in, we're watching that. This is turned all the way down. I'm going to ease it up. And I'm just going to stop and check current draw. No major shorts on the input, looks like. Current stays at 0. We hit somewhere around 70, 80 volts. It should be trying to start. Or not. Okay. She didn't do anything. Oh, wait a minute. Oh, it must have tried to start. We've got 270 volts there. 280. Why is it slowly creeping up? That's a new one. Well, the reason it's not putting out 12 volts is because this PFC voltage has to get to, I want to say it's like 340, 350, somewhere in there before it'll kick off the LLC part of this thing. And it's kind of coming up very, very slowly. Yeah, 302 volts. I did want to see what voltage we had on pin 13, which is the power supply for this chip. But then I saw this creeping up slowly, and it kind of worried me a little. I'm going to turn this on. What do I have on pin 13? I'm going to check on this capacitor down here. Yeah, 18 volts. That's what it should be. So the startup circuit is working normally. It's taking the, I talked about that in the last live stream. The startup voltage comes from the drain of the PFC MOSFET, whether that's sitting at 180 volts or 400 volts. That's just for startup though, and then the other circuit takes over. 322. I'm kind of curious now to see what happens if it tries to start once this gets up to like 340, 350. Let's find out. It's not putting anything out now. It's not running. The LLC part's not running because this has not reached the threshold. And this should not be taking this long to get up there either. Is it going to try? I think I'll have my hand on the off switch. And is it going to just keep climbing? Still climbing. It seems like it slowed down a good bit though. Why is that climbing so slowly? Well, the PFC has to be running to boost from 170 if you just rectify the voltage. it's boosting it. Not quite enough. And the LLC is not running. I'm tempted just to give this board a good cleaning and see what happens, because I'm a little concerned about this film on here doing some weird stuff with the feedback for this PFC. I never saw it try to just for the LLC part to start running. I never saw it. I may have missed it. It could be in shutdown, but I don't think it's in shutdown. If it was in shutdown, that PFC will stop running also. It just shuts the whole thing down, which is one of the pains of troubleshooting these boards. The PFC and the LLC, the controller, for generating the 12 volts, is all in one chip. Whereas on the old PS4 power supplies I used to work on, you had a separate chip for PFC and a separate one for driving the 12 volt converter. So you could actually, disable one and just run the other or something if you needed to, but you can't do that here. It's all or nothing. All right, we seem to hold about 379. This whole thing's going to blow up in my face in a second, isn't it? Nah, maybe not. That's weird. All right, I'm going to turn it off. She's pretty well stopped at 379. All right, let's turn it off. What do we think? Is it going to blow up? Well, the PFC is running. Do you know the analog of the chip DAP049? I would need to check my notes. DAP049 does sound familiar to me, though. Let me look at my notes. Where are my notes? Documents, PS5. No, actually PS4. That's a PS4 product. DAP049. DAP049, 049. All right, let me just find my notes. DAP049. Oh yeah, now that one, I chased that one for a while. That is I think it's an NCP 13992 AF. There's if you look up that NCP 13992, there's a bunch of revisions of it. And not all the revisions were available when I was trying to find a replacement from Mike Mauser. Because I tried the AB. I could get the NCP 13992 AB. But I'll show you. See, how do I change this? Properties. No. Yeah, that one. Well, that didn't work. I was trying to change to that window, and it said, "Oh, well, I've got it turned off. That's why." I gotta get rid of everything else. There you go. DAP049, I think, is an NCP 13992 AF. The AB would try to work, but something wasn't right. I can't remember. It's been a long time since I messed with them. So that's what I think it is. And if you look up an NCP 13992, you'll see that the pinout matches perfectly. But there's different revisions. And the revisions had to do with how it acted under certain circumstances. I think now I remember what it was. I put in a AB, and it worked. But if you disable the supply, You know how the 5 volt ran all the time on those. If you disabled the 12 volts and tried to bring it back up, it wouldn't start back up. And it was something to do with the different revisions of it between there was an AA, AB, AC, AD, AE, AF. It was how it responded to being shut down and brought back up or something. Anyway, that's all I can tell you. It was something to do with that. But yeah, look up NCP 13992. But looking at the data sheet, the only thing I could figure was the AF model, and I could not get it. It wasn't available. I had to get the DAP 049s from overseas. Anyway, that's all I know. Yep. So let's stick our hands back in this supply that we just had running, or not. How about we discharge this thing? Then I'm going to clean that board off and see what happens. All right, we're down to 2 volts. I'll take that. Let's see if we can get rid of some of this dirt. You can see it coming off of there. All right. So what do we think? Did that do anything at all to it? Cleaning it off? Probably not. Where is that window? Sorry. All right, I'm going to try to give it some power again. See if that voltage comes up any quicker. Ooh, let me get that meter back in the shot here. Sorry. Still not starting. It didn't start at all that time. Or, well, no, it is started. Look, it's generating 200 volts. So it's acting the same. It's boosting very softly and gently. Which I can only assume is just a bad controller. That's weird, though. Never seen one do that. Very strange. Okay. Another DAP 053 it is. So yeah, cleaning did nothing. Just made it a little nicer to handle, I suppose. Speaking of handling, discharge this bad boy before we go much further. Because 300 volts hurts. Okay. It didn't read shorted, but yeah, that's likely is the issue. That is the controller for the PFC. Let's get it off of there. Maybe I'll actually add some leaded solder to it this time, just to make it a little easier to remove, lessen the chance that I popcorn that board. Okay. Oops, come on now. I want to pop it up, but I don't want it to go flying. Fighting against this glue. There we go. She is off. I'm going to set it to the side. I don't really know if it's bad or not, so I don't want to throw it away at the moment. Could still be good. These chips aren't cheap. Yeah, that's right way. Touch these up a little. Okay, I'll leave that alone. All right, we've got a new controller. I did put it in the right way, didn't I? Yes, I think I did. Pin 1. Is that all it needed? Get our meter back in the picture. I need to hook back up the leads. I forgot I disconnected it. Across the capacitor there. All right, bring it up slowly. Still set on 5 amps. No, we're still acting weird. Look at that. Yeah, the chip is getting full voltage. This meter's not lying to me. You know, it's 310 volts and climbing. The chip is getting 18 volts. So, do we have a leaky PFC MOSFET? Like I said, it has to be running to boost that voltage that much. Otherwise, you just get, you know, roughly 170, 180 volts. This is a 120 volt line. Fanuc, I don't know anything about Fanuc power supply boards. Maybe. You can email me if you want, toltecmerc@gmail.com. Sloth GSR. It's toltecmerc@gmail.com. But I can't say I've ever worked on Fanuc. I know what you're talking about, but I've never worked on them. $364. Okay. Should be running. Is not running. Let me discharge this thing. And I need to discharge it completely down to 0 if I can, because I'm going to be making measurements in this PFC circuit. And if you've got like 2 or 3 volts, you know, on there, it messes up your resistance readings. So now I'm going to give it the old short. That, or I have been known just to put like a clip lead across it like this and let it sit there for a while. And hopefully not forget to remove said clip lead when I go to turn it back on again. I want to drain those capacitors completely. And I know they'll charge back up a little because of, I think they call it like dielectric absorption. That big electric capacitors tend to do that. That's why you see the voltage going back up. I didn't check the reference, the feedback voltage. I doubt I went straight to 2.5. Well, it can't go straight to 2.5 because it's divided down. You won't get 2.5 there unless you are getting 395 volts. Or your resistors are messed up. Maybe that's the issue. I mean, the resistors could be damaged. They look good. We'll get there, though. We'll get there. All in good time. I'm just draining these capacitors really well. All right. Still charging back up a little, but I got rid of most of it anyway. So what is going on? And those 7.5 meg resistors are rather hard to measure in circuit. What do we read diode wise on this PFC MOSFET? I'm sure it's not shorted. We would have blown a fuse. 0.44. What is the normal reading? What is the normal reading there? Okay. What is the normal reading around that PFC? There she is, right there. So with the red probe on the negative terminal of that big capacitor there. Let's see, gate. Is that the gate? That can't be the gate. Hmm? No, it must be the source. I think I'm looking at this thing backwards. The source would be tied to ground. Drain and gate. I mean, right on the money. Look at that drain reading, 448. That's right on the money. Of course, I used the same meter when I made those readings. And 706. Yeah, that's right on the money. Perfect. None of these readings were like even off a little. I'm going to look around this DAP053 again now that I've changed it. Although I don't think it was bad. Pin 2, 562. Is that normal? Yeah, 556. 1, 2. Yep. 3. Yep. 4 is ground. 5. 650. 6. Yeah, 630 is what it says. That looks pretty close. Skip 7. 8. Yeah, it looked normal. 9. Yep. 10. 11. It's usually 508, a little lower than usual on 11. 12, no connection. 13. 14. Yeah, in the 6s. 15. Yeah, 16. Yeah. What about our diode? Or a good bit of capacitance there, 0.8. So this is on the boost diode, what you would call it in the PFC circuit. 0.45 on one side, 0.8 on the other. Right there, 449 and 830. I don't see a problem. I don't see a problem. Trying to think, what else would make that voltage? The feedback resistors don't look damaged. These right here, those 7.5 megohms. This one just has those two resistors and this 95 k ohm to ground right here. Some of the other models have a 750k in there also for some reason. Can't say I've ever seen one act that way. Boosting so slowly like that. And the LLC never takes off. I want to look at, all these look healthy. This is part of the circuitry for where it samples the line voltage coming in. We looked at this stuff earlier, didn't we? These opto-isolators. Let me swap back. I'm sorry. Turn that back off. Gonna be another weird one. 1.18 on pin 4. I think that's normal. Of this opto-isolators, where are they? Right there. That doesn't look normal then. I was looking at the top one here, which is IC52. And I got 1.18. You'll get, I think it's got fuzz on there. I think you get nothing, or OL, on that one. But pin 2 is measuring 1. Not pin 2, it's pin 4. Where's IC52? Right, 52. Make sure I'm looking at the right one. See, this one's got a 1004 in there, which is odd. They change these up. That is strange. Because the one that I examined when I made my schematic had a 1013 in it. Apparently they just throw whatever in there. These are all 1004. That's 1009 down here. Anyway, so this is pin 1, 2 on the cold side. This is 3 and 4. 3 OL, 4 1.18. That's odd. 1.18. That's hooked to your power supply. Let me turn that back on. Where I was checking was right here. IC52, pin 3 and 4. This is on the hot side of it. I've got it labeled down there. Let me check the other ones just in case. But yeah, there's just pin 3, OL, pin 4. That's not right. All right, let's go down here, pin 3, shorted to ground, pin 4. That looks normal. And then we come down here to this one, 0.557. I think that's all normal. So up here, 1.18. Let me switch back. Why is that 1.18? I don't think it'd be the opto isolator though, because this is the you might say collector emitter of a transistor is what this is over on the left side, with the base of it basically being, have it light exposed to it from the LED on this side. So this should just be pretty much wide open. I don't think it'd be bothering my diode rings. What I'm trying to say is, it's like checking on the collector of a unbiased transistor. So what have we got going on here? There's that same reading again. Why? This is an NPN transistor. And my meter went to sleep. Come on. Time to work. But it seems fine, base collector, base emitter. I'm just hitting some of these diodes around here. But that, where I'm getting that 1.18, if I'm not mistaken, part of your circuit for generating the 18 volts to supply the DAP053. Just looking at this to make sure none of these big heavy transformers have gotten knocked loose off the board or anything. Doesn't seem to be. But that is odd. Why is that so high? What's it supposed to be? Like 0.7. 0.7. Yes, worms, it is making me think. And I don't like it. We got no time to be thinking here. We want quick fixes. Quick, painless fixes. I'm just looking at the schematic, trying to figure out. See, I'm checking that right here. That should be 0.7. This is isolated by 251K resistors. That's not going to bother us. So you go this way, you get to this transistor, which this is not running. This is what generates the voltage to run the DAP053 over here once everything's up and running. And this transistor seemed to have been good. It measured good. So what else? And see, this is what goes on to... That's strange. So did I not measure? That goes to pin 13 of that chip. Did I not measure that there? Did I not measure? I don't remember measuring that on pin 13 of that IC. Unless I was not paying attention when I did it. Yeah, right here. No, it's 0.7. All right, what's going on here? 0.7. And that runs along over to here. And if we remember, that goes to a jumper over here. I seem to remember. That jumper is open. Look here. 0.7. This is the side going back over to the IC, pin 13. 0.7. 1.18. What the hell? Let's check the resistance of this 0-ohm jumper. 17K, that's close. It's a little out of tolerance. She's a little out of tolerance. 17K. 17K for a 0-ohm jumper. I've never seen that. And if you look at it, it's not damaged in any way. I mean, let me zoom into this little thing. Is it just a bad resistor? Did it just fail? It doesn't look burned. Let me switch to the full microscope view. Nope. That's not what I wanted. Where's the microscope? There we go. See if I can get it in good focus there. I mean, does it not look healthy? So, that's going to be our problem. I don't think I have any of these 0-ohm jumpers like that. I mean, you can put a piece of wire across there. It's the same thing. Let me see what I have. That's like a 1206 size or 1210. I have a book of resistors. I wonder if there's any zeros in there. Here it is. Maybe there's some zeros in here. Yeah. Yeah, there is some. Never looked for them. 1% tolerance. Well, thank goodness. But that was a weird one there now. I'll never look at 0-ohm jumpers the same again. That's one of those things you just kind of assume is good, which I have learned over the years will get you, will lead you astray when you start assuming things. When you start assuming things. %1 of 0. 0.0. I don't know. So let's see if this is a good replacement. Otherwise, it's getting a piece of wire. Because they literally did this just to jump over a trace. I've only got 1 0 on mine. Man. I'll order some of these with 3 zeros on it. See if I can get those in time. Is that all that's going to be wrong with this thing? So I'm going to hang on to that DAP053 though. I think it's good. He gets all the blame, doesn't it? And probably rightfully so. See if this thing crumbles as I take it off. It doesn't look damaged at all. Nope, it stayed together. Never seen one of those fail though. Just facing anything can fail. Unless it opened because the DAP053 was damaged. I tell you, we'll see if this thing works. And if it does, we'll put that old one back on there and see what happens. For science. All right, now that diode reading now. Diode mode. Yeah, 0.7. Much better. Okay. Is that all of our problems? Is that giving us our weirdness with the PFC? Or is there other issues? I don't know. Let's find out. Can you see everything? Maybe a little less glare on that. Bring it up slowly. There we go. Yep, we're running. Check this output voltage. 12 volts on the nose. There's 10 amps. Looking pretty good. So yeah, a 0-ohm jumper. Tell you what, I will go ahead and put that other DAP-053 back on there. Let's just confirm whether it had a problem or not. I suppose it could have shorted, although we didn't measure a short. When I went through those pins, I didn't have a short. That's what really messed me up, though. I'm like, I knew that, you know, where that was connected on that, I'm trying to say, opto isolator, that was the same voltage going into the IC, and I had already checked diode mode on pin 13 of that IC, and it did not measure that 1 point whatever. How is that possible? It's a direct connection. Well, through a jumper, it's a direct connection. All right, that's working. All right, here, let's shut her down, discharge it. We will swap out that IC, put the original one back in there, just to prove that point. Was it bad? Was it not? Okay, we're down pretty low now. All right, so where'd I put that chip? It's right here. Trying to get it oriented right so when I go to grab it, it's ready to go on. Find my tweezers. Okay, get it turned the right way. All right, that's a good one. This is the one I took off originally. Seat that back down a little. Not the prettiest on those legs. I'll go ahead and touch them up. Go ahead and put a lot more flux under that chip that I'll have to dig out later to blow it out from under there. Yeah. Okay. All right, does it work with the original chip? I'm gonna let it cool off just a little. I don't like to run it after I've just cooked it at 350°C. Maybe clean off some of this flux while it's hot. Okay. I like to start off around 5 amps. Our load is still connected. We're checking our PFC voltage. Get rid of the glare. Just go. Yeah, she runs. So back in my parts bin goes the chip. She runs just fine. Let's go ahead and check it to the full 31 amps. Let's see. get where I can watch the output voltage as we ramp it up. Okay. 10 amps, 11, 12, 13, 14, 15. Doing pretty well. 20. They usually, at full current, they'll drop just below like 11.99 something, or 11.90. 25 amps. 26, 27, 28, 29, 31. That's 1201. Full rated current, 31 amps. That's a good, healthy supply. That will power a PS5 happily. All right, how many is that we've fixed? Oh, we fixed 3, haven't we? Unplug it. Discharge it. Okay, that looks pretty safe, down to about 3 volts. So, just a little more cleanup on it. Still got some flux around. That jumper I replaced, but not too much flux. What are we talking about here? You replaced one of those with the power plugged back in? Yeah. Yeah. I don't know if I ever tried to do that. I have tried a few times using my discharge tool while it was still plugged in. I couldn't figure out why it wouldn't discharge. And finally figured out, oh, there's Chip. There's a gentleman who sent me these power supplies. Thank you, Chip. At Chip Camels. So far we fixed 3 of the 6. Let's see. Let me do a little more cleanup on it, and I'll put it back together. I'll take this thing outside and blow this dark soot off of it. On the top side, I've washed it off the bottom side for the most part, the solder side. So that one was fixed for the cost of one 0-ohm resistor. Okay, let me go outside and blow this off a second. And maybe the covers as well. I'll be right back. I'll be back. Okay. We are back. All right. This is another ADP400FR. That is working and has been load tested to 31 amps. Let me stick a note on it. Scribbling. Tested at 31 amps. Okay. All right. See, I have. Well, that's 3. Okay. Okay. I have 3 more in the floor here. What time is it? It's 11 after 11 here. Should we try to do another one? Anyone left? Oh, Worms is still here. We have several people still here. Thank you. Thanks for hanging out. All right, let's grab another one. DR, a 400 DR. The original PS5 power supply. All right. The lovely emerald green 400 DRs. Should be nothing on these capacitors since they've been sitting in a box cold for who knows how long, and there's not. What happened to, I guess I turned that off. How's our fuse? Good. And our fusible resistor. If I can get to it. Good as well. So we don't have shorted MOSFETs. How about on the output? Climbing up, charging some caps. So, no catastrophic shorts on this one either, it looks like. What about our DAP 053? Pin 1 is shorted. Okay. Pin 2 is shorted. 3 is not. 4 is ground. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is shorted also. So 1, 2, I don't think it was 3, but 1, 2, and 15. 1, okay, let me grab that DAP 53 that I dropped back in there, in my parts bin, because that's where we're going to start. We've got shorts all over it. Let's see. Let me add the microscope back. Oh, it is back there. I'm sorry. And I guess I should add some leaded solder to this. Come on. It doesn't want to let go of the board. It was glued down well. Okay. Turn it around. Okay. Pin 1 is turned the right way. That's good. Is that all she needs? Are all of our shorts gone now? 1 is good. 2 is good. How about 15? Yeah. Yep. Okay. Let's get set up to monitor the boost voltage and stuff. Okay. What do we set for over here? 5 amps. Where's the end of my cord? Okay. Easing her up. And we started right up. She's working. Just needed the controller. Yep. This one was a very simple one. Yeah, so the previous one, you can go back and watch the stream. The previous one was, it was a bit of a pain. It really was. Well, not the previous one, I'm sorry. The previous one was really easy, I guess. It's just a jumper. It was the one before that. It was supply number 2 of 6. This is number 4 of 6. It was number 2. Yeah, I wish they were all like that. I don't know. Well, it took me a while to find that last one, I guess. But okay, I guess I just need to give this one the full test at 31 amps before we can pronounce it completely healed. See if I can get my leads in there. 1205. And it fell out. All right, out of the isolation supply. Back there, into the outlet. That doesn't look right. Now we're running 413. Let me give it some more load here. I don't think it started up at that load. $31 amps. Let me run it back down. There's no load. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 23, 24, 25, 26, 27, 28, 29, 30, 31. How about 32? Yeah, I should do 32. All right, that's about all you can ask for. That's all you can ask for. Maybe a little cleanup. Get that flux out from under that chip that I kind of loaded it up with. I have not discharged this. Let's do that before I start handling it and forget and touch the wrong thing. Might say a bad word. Nah, maybe not. Okay, that's discharged. Let's heat this thing up. Whatever. Gotta get that flux out from under there. How does that look? Not bad. Not bad. Ooh. It's got some alcohol there, I believe. Oh yeah, this is one. The DRs are the ones that's got the got that 750K resistor in line for that feedback. For the power factor correction, if you follow it, there's a 7.5 meg, 7.5 meg, around through here, 750K, and then on around, and we end up with, I think it's 100K to ground on, where's pin 2 on this thing? Where is it? Oh, it's way over here. 100K, Zener, pin 2. Anyway. Well, that's another one fixed. We have 2 left. Now the console would never need 31 amps, I don't think. Now I still have that one that's unstable over off the side, and I'm going to take another look at it. We're going to take another look at it. It's still over here. But for right now, I think I am going to grab some lunch. I do appreciate you all coming by, though. And how about, let's see, tomorrow is Friday. How about tomorrow we'll tackle the other 2 in the floor. I'm looking at them in the floor down there. How about we tackle the other 2 and see if we can knock those out? Yeah. Okay. I like the sound of that. So anyway, thanks for coming by. I appreciate you watching the stream and joining. Hey, there's Rusty Russ. Have you been here, Russ? I didn't see you earlier. Were you here? He's probably watching Andy. Well, thank you for coming by. Thank all of you for coming by. Yeah, I'm going to take a little break right now, and I may take a look at the PS5. May play a little bit of Diablo 4 over here. I don't know. But we'll do it again tomorrow. About the same time. I'll try to get an early start tomorrow. So if we have any tough ones, maybe we can chase them down. Anyway, so I'll see you all tomorrow, hopefully, if nothing happens. So bye for now, guys. Thanks for coming.